makes things easier.
Yeah. You need to stay like interactive with these guys.
Yeah.
Cool. I think they're only one person.
Just need an eraser for this board. I'll look in the classroom. I think there's one in there. I can grab it. Okay, okay.
What they did. So then that's why I just copied it. Because usually I include things that you guys yeah, that's why I did it.
Oh, I'll erase it. Don't worry. Yeah, thank you.
No problem.
Thank you. I was just trying to Okay.
Yeah, so I just like looked at these and it's like all like in the same format. You did a good job figuring that shit out. Well, like the thing is I can't really troubleshoot.
Okay, I think we're gonna start today's lecture. If I can get everyone's attention, I think we're gonna start. Cool. Good morning, everybody. This guy's just having breakfast. So my name is Johnny Kalambe, and I've been a part-time teacher for a year now, but I've moved on to teaching the boot camp, and this is my first boot camp lecture. Yeah, thank you. And my full-time job is as a software engineer at a company called Axiom Labs. Yeah. So today I'm going to be teaching about a few things around authentication and security. And I know it's relevant to all of you because you're all starting to integrate it into, I believe, is it Tiny App at this point? Okay, perfect. I will start off with a disclaimer. I am not a security expert. But, fun fact, I was interviewed by a BBC reporter from the UK who thought that I was one. And it's a bit of a funny story. And that story starts kind of where you guys are at now, which was at a boot camp. So a couple years ago, I took the boot camp, and my friends and I were working on our final project. And we wanted to come up with an app that basically would make social gatherings more fun for everybody. And we thought, you know, what if you could go to a nightclub or a party and the music wasn't trash? How great would that be? And so our final project was an app called Auxcord, which was basically a collaborative jukebox, which is basically you go to an event and you see all the songs that are coming up on someone's Spotify, and you can vote them up or down the list. And we built that. It went really great. We ended up winning. And then when I was job searching, as you guys are going to be at some point, I wanted to kind of beef up my resume and my portfolio and have something more than just Tiny App on there. So I ended up writing a tutorial on how to connect to Spotify's API. And I put that on YouTube, and it got a whole lot of views, well, more than I was expecting at least. And then eventually, someone emailed me or reached out to me on LinkedIn saying, hey, so there have been some recent hackings in Spotify, so we wanted to reach out to security experts to ask about how it works. Would you mind doing an interview? And keep in mind, like, my qualifications were having written one tutorial about how to connect to Spotify. So But you know, I didn't say that to him. I said, sure. I'll do the interview. So this guy ended up interviewing me about security tokens and things like that. Now, even though it didn't make me a security expert, it did make me very familiar with third-party authentication using OAuth, which is what we'll be touching on because, in my opinion, it's probably the most powerful and reliable way to authenticate your users. But we have a lot of concepts to cover before we even get to that. So let's start with the very, very basics, something that I think some of you are familiar with already if you did yesterday evening's work, which is cookies. OK, so what is a cookie essentially? Can somebody tell me?
Bit of information stored inside the browser so that the server can know what computer this is.
Exactly. You pretty much, what's your name?
Brian.
Brian. Brian just pretty much hit the nail on the head. It's a bit of information stored on the browser so that the browser can know who you are. Essentially, if I go to Heroku.com and take a look at all the apps that I've put up, basically I have to log in and let Heroku know who I am, sorry. And then once I do so, then it's going to put a cookie on my browser so that if I access another page and make another request to Heroku servers, they don't have to ask me to log in all over again to let them know who I am. And if you want to see where the cookie is, you can find it right over here if you open up the DevTools. So these are the cookies that Heroku is storing on my browser. Yes, of course. Let me see how. If I can figure out how, there we go. There's not much to see, it's just a lot of random characters, and we'll talk about why it looks like that in a bit. So these are cookies, and basically this is attached to every subsequent request that I make to Heroku servers. So if I make, let me see if I can find the request that was made. So when my client made a request to Heroku in order to receive this site, it attached to the request these cookies. And so now when the servers over on the Heroku side received that request, it was able to tell that that request came from this user. Now, what kind of information would you want to store on a cookie? Yeah? Language settings could be one of them. What else? What's your name, by the way? Grayson. Cool. What's the most simple thing? Like in the context of this, me having logged in and wanting to go to my apps page, what is the most basic thing? Yeah? Username and password. We want to know the username and password. Well, actually, we don't. You want to know username and password when a person logs in. At that point, once a person is logged in, we just need something to know who the user is. You're onto something. Like, we do want to know who the user is, but it isn't necessarily the password that needs to be saved. Yep. ID, exactly. Usually you want to store something like a user ID. Any kind of identifying information about the user is what you want to store in a cookie. And later on, we'll talk about why the password is probably not the best idea. Even the username wouldn't be that bad, but because that can change when people change their usernames, that's not necessarily the most reliable either. So you want some kind of unique identifier, and the most simple one that you can use is an ID. And now every subsequent request will come attached with this particular ID, which the server can then use to reference and get all the other information that it needs about the user, like their username, their email, and all the other apps that they have in their Heroku account. And you can take a look at your cookies, as I'm doing now, by going into the Application tab. And you can clear them from here as well. If I hit Clear Cookies, and I hit refresh. Oh, actually, I need to clear all my storage, actually. Clear storage. And hard reload. Oh, I guess it's storing information somewhere else. It has some stuff in local storage as well. Let me clear local storage. I'll talk about that in a bit. Now when I refresh, session storage. Where is it storing this stuff? So Heroku's storing my information somewhere that I have no idea about. Let's try something different. Let's go to, oh, I don't have a Facebook anymore. YouTube maybe? And clear site data. Now when I hit refresh, YouTube has no idea who I am. So the reason why I ran into a bit of a trouble here is that when I was clearing the cookies, it still persisted my session because I wasn't exactly sure where it's storing that information. Because there are different options. There isn't just cookies. There's also IndexedDB, there's cache storage, there's application storage. And I'll go over in detail over what the difference is between each different one of those. But when I clear site data, yeah, for some reason Heroku is still being persistent. But with YouTube, it was able to actually clear my session. So let me just go a little bit into more detail about each of these is. You got local storage, you got session storage, you got IndexedDB, you have WebSQL, and you have cookies. The most basic one is cookies, and that's the one that we talked about. It has some unique identifying information about who you are, and maybe some other things like languages as well. And then you have session storage, and you have local storage. Does anyone know the difference between those three? Yeah.
I think local storage is like stored on your device, and it's like it doesn't really expire, whereas the session storage it expires after you exit the session.
Yeah. So session storage expires when you close the browser. Local storage does not. And local storage and session storage information is not sent along with every request. I have a little chart here that outlines the difference between the different ones of them. So cookies are manually set. They are stored on the browser and a server, and they are sent along with request. Local storage and session storage are on the browser only. The difference between local storage and session storage is that session storage expires when the tab is closed, and it's only accessible from the same tab. So if you go, you have the session storage information, and you open up a different tab, that information will no longer be available. And then you have some other things like IndexedDB and service workers, but those are things that you probably don't want to worry too much about unless you're going to be storing a lot of information on the browser itself. And that's typically something that you'll do when you make offline-only apps like PWAs and things like that. Any questions so far about cookies or about session? Yeah?
I was just wondering what sort of stuff is like stored in local storage.
Let's take local storage. Local storage is where you might save information about if somebody was signing up or filling out some kind of form and they log out. And then, yeah, they close the browser and then come back. You don't want to have them fill out the form all over again. That's the kind of thing you would store. Settings are what we store in local storage. Like at my work, we have a project management board. And each user will have certain filters for projects and certain settings. And we usually store that in local storage as well. That's a good question. Any other questions? Yeah?
So the local storage, I guess, it's actually stored in the computer, user's computer. But then cookies and the session, where is the information stored? Is this with a server or it's on the browser/user?
That's a really great question. What was your name?
Renee.
Renee. So Renee asks, cookies are stored, local storage is stored on the browser. Where are all the other kinds of information stored? Now, everything you see listed here is all stored on the browser itself. Local storage, session storage, IndexedDB, Web SQL, cookies, they're all stored on the browser. However, the cookie has references information that is stored on the server as well. So the cookie itself is not stored on the server. It's stored on the browser, but it gets sent to the server with every request. When we saw that little network tab and we saw the cookies that were attached, let me see if I can find it. These cookies are on the browser, but every request that we make to YouTube, we attach those cookies along to let us know, hey, I'm asking for this page, and by the way, here's my user ID. Now, there is also sessions that are stored on the server side, but that's something a little bit different. So a server session is kind of like a session that's stored on the server, but is kind of tied to a cookie. So let's think about something like a user filling out a form. If you were to store that in local storage, then you say this particular user has filled out all these fields, and you put that into local storage. If you were to store that same information using a server-side session, then you, on the server side, that is in memory in your node.js, are storing all the information that the user has filled out, not in the database, but still in memory in the server. And you have a unique identifier for that session on the client stored in a cookie. And then when the request is made, then you use that cookie to reference the server session. It's a little bit confusing, but there's a difference between session storage on the client and a server-side session. A server-side session is information stored on the server that is referenced by a cookie. Yeah, so really, everything you see on here is going to be stored on the server, on the client. But if you want to store temporary information on a server, you typically do that with a server-side session. And I'll talk about the exact kind of code that can do that for you when I look over the code a little bit later. Any other questions? Yeah?
Are those local storage kind of like user specific?
Pardon me?
Are those local storage like user specific?
It is user specific, yeah.
So they're kind of like linked to the cookie.
Well, it's not necessarily not user specific in the sense that like only one particular user will be able to use it, but it's just one client, I guess. So maybe it's not user specific in the sense that it's tied to a user, but it's tied to a client. So if I have some stuff on my local storage, and then I open up a browser on a different computer, there is no connection to that. Unless Chrome has some kind of settings where it can sync that stuff, which might.
If I say this go over there and I log in as different user, would those forms be filled with the same?
That depends on how it's stored, but actually it could be. It could. So let's say I have YouTube and I have some kind of filter, like I don't know, child-friendly only content on, and that's stayed in local storage. If that information is not specific to a user, then if you go on my computer and you log in with your account, you're going to see that exact same filter. At the end of the day, it's up to you, because local storage is literally just key and value pairs. How you interpret that is completely up to the code you write. If you write code to interpret it based on the user, then of course it's going to be user specific. But if you don't, then it's not. So to answer your question, it's up to however the person wrote the client code interprets that local storage. It's literally just key and value pairs, so you can do with it whatever you want. Really great question. So we kind of answered the question of what happens when someone goes from page to page, and we want to keep that information there. But now we got to talk a little bit more long term. How do we store user information? And I think we've all touched that a little bit. Have we put passwords on our Tiny app yet, or no? Not quite? You're working on that today. Perfect. OK, so we're going to get to that today. And have you learned about databases at all? Nope. OK, that's OK. I don't think we need to for now. We can Let's imagine that we're just storing all the passwords on our server. Don't ever do that, but let's just, for simplicity's sake, assume that we are just storing them within an object inside our node.js file. How would we do that? Give me a high-level overview of how you would store that password. It's not a trick question, by the way. Just a key value pair, and that's it. And you would say, I don't know, like user, or even like an array of users or something, or user ID, and then like you have their information or something like that. I don't want to say wrong. What's dangerous about that?
Side by side. Like having them side by side, like if you're having them in an object, it's like they're paired together.
If you mean like, let me.
Like username and password as like key value pair.
Mm-hmm.
Having those two things accessible together, would that be?
Yeah, the fact that it's accessible is a bit dangerous. And let's say, I don't know. Let's just write an example. So inside our Node.js, we have an object that looks like this: users equals, and then in the object we have user 1, 2, 3, and then my password. And then you have a whole bunch more of these, all within the object. Yeah?
If you get the object itself, you get the whole database of passwords and username.
But that's not that big of a deal because you have your Node.js, and then when somebody logs in, they send in their user, and then you can say, if entered password equals users entered username, then you log in. Else, blah, blah, blah. My writing is really, really bad, but you kind of get what I'm saying here. If the entered password is the same as the key, the value of entered username inside the user's object, which is the password, then we let them in. Otherwise, we don't. Yeah?
But if you're doing that, then you're just checking if that user exists in that object. Like, you could have a separate password that doesn't, or if you're doing like an ampersand or something where you could keep on adding conditionals, but you're still accessing that object directly.
Yeah.
And so it's dangerous because like you could potentially shift or something, like shift the object to get someone else's password, or like you're still inserting code into that username, like for that conditional, so you could potentially get the object.
You could potentially get the object.
And you could potentially return the object.
That's true. And Nima, what do you think?
I'm just thinking more about like security-wise for the client. So if he goes on my website, puts his password and username, I as the developer, then I would have access to his password, which is not very safe for him. If I don't have any encryption, nothing. But I don't know.
Yeah, Nima's more on the track that I was thinking. Not that Bryson, right? Bryson? Grayson, my bad. I don't know why I thought Bryson. Not that you're wrong. From a logic perspective, yes, it is a little bit iffy. You're completely right. But the more dangerous side is the security side. I have an object with keying values and the password is stored in plain text. Even if we were to add the database layer, which you all will later, having this kind of logic, username, and then like email, blah, 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 and then password stored as is very, very dangerous because not only a hacker, but even you as a developer having access to that password can be really, really dangerous because, I mean, if you're all working on a small project, it's not that big a deal, but if you're working at a big company and you have one person who's disgruntled and decide, oh, you know what, I'm gonna go and mess with everyone's account, or even one person's account and take all their money, then you got yourself in trouble. So we're gonna kind of, over the next little while, add more and more security measures so that we can make our app more secure in the way that we store our passwords and eventually in the way we authenticate our users altogether. So you mentioned Nima? Renee. Jesus Christ, I'm terrible with names. Renee mentioned encryption, which is the very first thing that we want to talk about today when it comes to security. What is encryption? Yeah.
You can take some text, garble it up through some algorithm that you have,
Yeah.
and then you turn that algorithm, then you return that garbled text. Which means you have to have some kind of way to decrypt it to use the normal text.
Exactly. So you have password 1, 2, 3. Greatest password ever. Goes through some encryption function, and then out comes out 9B734A7 whatever, some random piece of text that no one can interpret. And that's good because even you as a developer cannot look at the code and know what someone's password is. Instead, what you do is you store the encrypted password. And then when someone logs in, you take the password that they've entered, put it through the same encryption function, and compare the output to what you have inside your database or just in memory. And if they match, then that means they've logged in with the correct password. And through this entire process, you have no idea what the password is. You can put the debugger in your server, and at that very line of code, you will not be able to see what the password was. And that's really useful, but it does have its drawbacks. Because a lot of encryption functions are they become popular and they become used a lot. And what happens is, actually, I'll let you all guess before I say it. What's one way that people can find encrypted passwords? If I'm a malicious hacker and I wanted to hack into your Tiny app and you're using bcrypt to store your passwords in a secure way, what's one thing that I could do to try and kind of find my way in? Yeah? If it depends. If you know the encryption algorithm, then yes, you could. If you know the encryption algorithm, then you could go backwards. What about if you don't?
High number of attempts, so just keep feeding in different strings until you get the correct one.
Yeah, that's something called brute force attack. Unless you just try as many as you can and eventually you get it right. What's another way?
Are you just trying to log in, log into their account, or are you trying to get their actual user and password?
Let's say you're trying to figure out the password. Yeah?
Get a couple of examples, then you can form a pattern and just reverse engineer what the encryption function.
If the encryption algorithm is weak enough, you probably could. But I mean, I think a lot of the stronger ones like SHA-1 and 2, like the output is so random that it'd be really, really hard to kind of find some kind of pattern. But like ideally, like let's say if our encryption algorithm was to shift every letter by 2 up in the alphabet, then I'm not going to do it right now. It would take me a long ass time and it'd be embarrassing. But you can imagine another word that is the same length but has a bunch of other random numbers and letters. Then yes, someone who's a hacker can eventually like look at it and figure out, okay, yeah, that's what's going on. Yeah.
Nowadays, it's probably publicly available to just know where to look.
That's true.
It's not even just publicly available. It's probably stronger nowadays.
Yeah, it's true. And that's what happens eventually. Eventually, people can find patterns, like maybe not people, but there are computers that can look at a whole bunch of examples and kind of see what's going on. So it's not impossible, you're right. But the stronger the algorithm is, the more difficult it becomes. If you don't want to go that route and trying to figure it out, what's another approach that you could take? That's true. If you have access to the client and the connection is not secure, you could technically do that. Pardon me? James, well, he mentioned something to intercept the client before.
Like catch it before it goes to
Yeah.
recording. So it could be any form of like.
Yeah. Exactly, yeah. Now, there's also something called a dictionary attack, which is all about taking the most common password. Because what often happens, if I don't have the computing power to reverse engineer this hashing algorithm, what I can do is basically keep track of the hashes of the most common passwords. User 123, password 123, password, I don't know, the password is whatever it is, your mom's name or something like that, and have a log of all of those, or a dictionary of all of those, and what English word or what password they converts to them, and then I can use that dictionary, and when I have access to a database with all the hash passwords, I can just look at and say, okay, well clearly these passwords, this one, I can find it in my dictionary, so that user's password is password 123. I have the dictionary.
They have access to the whole database.
Yeah.
You can see which one has the most consistent with the exact same encoded.
Let me see if I can find it.
Like just like let's say it's like a 16-row string, and he finds all the ones that are exactly the same, and he knows what the password is for those ones because he knows what the most frequent password is.
But isn't that global? Like, can you just pull that?
Yeah, it's online. There's rainbow tables online. You could find these. And
So it's just like it's an elegant brute force now.
exact, except you're not actually doing the brute force yourself. You're just kind of like, you already have.
Brute force stuff, because you're still going to have to guess. You have like the 10 most common passwords, and you're going to cycle those through on a given user if you have that information.
To get there.
And then,
To produce this, you're completely right. You are going to brute force to produce it. But I'm saying, because this already exists, if I'm a hasher and I know that someone's using SHA-1 or some kind of encryption algorithm that is common, then I don't need to do any brute force at all if I already have this dictionary. I can just look at it and say, oh, okay, I'm just going to look at this table over here and see what this person's password is. Like, let's say someone's is using it.
database of users and their passwords.
Yeah, exactly. You build Tiny App, and you use a common hashing algorithm to encrypt your passwords. Let's say it's used SHA-1, and I get access to your database. I'm a hacker, and I see that what's password 123, and I see this in your database as your user's password. I can tell from my rainbow table that this already exists. It's already logged inside that one of these tables as password 123. So I don't really need to do any hack. Like as soon as I got your database, I can figure out that your password is 123 because I already know based on this database of like pre-registered passwords and hashes.
Yeah. Okay. Well, that's super easy, but you just got to hack the database.
Exactly. That's yeah.
Like, there's still like this. Yeah.
Of course. Yeah, getting into the. Yeah. For Tiny App, that's the case. I don't know. For Tiny App, could be pretty easy. So yeah, I mean that's why a lot of people getting into the database itself is like a whole other thing. Yeah, we're not going to cover that today because, yeah, once you're in, you're in.
You know, like Zoolander when they're hacking into the computer, the files are in the computer.
I never watched Zoolander, but I know for a fact that like movies depict hacking in a very kind of weird way. Now, does anyone know the difference between encryption and hashing? Yeah.
Hashing, you can't get the result
Exactly. Hashing is one way, encryption is two ways. So encryption is what you'll want to use for files because you'll want to be able to have somebody change the encrypted kind of jumbled back to the file that you want. And then hashing is only used to verify if something is the same as something else because you cannot bring something back. Now, pardon me? Yeah, exactly. This is hashing. This is not encryption. I mean, if you can go back, if I'm shifting the letters by 2, then I am encrypting because I can reverse that. But if I'm using some random function that will convert that into a set string of numbers and letters that's always 3 characters long, then I'm hashing because there is no way to reverse that from this without brute force or something like that. Now, there's a couple things that I want to touch on before I get more into different kinds of decryption and encryption keys, and that is hashing with salts and with peppers. Does anyone know about that? So one way we guard against these dictionary attacks, because a lot of algorithms are already commonly used and have all their, a lot of common passwords are already recorded in these tables. A lot of databases use these things called salt. And a salt is a random string that is added to the end of your password in order to create the hash. And what that does is it makes it so that even if your password is 123, the hashed one inside your database is not going to be one that can be commonly looked up because it'll be password 123 with the randomly generated hash, which could be like @ $24 exclamation mark, whatever. So every time you log in, even if you pick a really basic password, the server itself will add a salt to it, and then that salt will be used to create the hash. And then basically whenever you log in, it takes the password that you logged in, the user that you logged in with, and then adds the salt in order to check if the hashes match. So that's like another measure of security. And there's another one called a pepper. And pepper, what it does is it adds one character. I think it's usually anything from the letter A to Z, uppercase or lowercase. And it adds that randomly in order to create the hash. And the difference between a salt and a pepper is that the pepper, I believe, is not stored in the database. And instead, when you log in, the password matcher or the server is automatically going to add all of the possible peppers. So that could be like, I guess, 26 times 2. And it's going to check against every single one of them to see if the hashes match, which can take a while. But I mean, for one person logging in, each one will take a fraction of a second, which isn't going to be that big of a deal. But that makes it so that no matter what, like your password will be pretty much random. And the important distinction here is that the salt is stored. So this like little extra exclamation mark, @ whatever, is stored along with your user, whereas the pepper is not stored at all. It's added whenever you it's added when you sign up, and then when you log in, it adds a bunch of possible salts, check the hashes for all of them, and then sees if like one of the 26, the 52 or whatever matches. Typically, you won't be doing too much of that. I mean, unless you get into security and work with kind of older companies that do that. We'll talk about some of the more stronger ways to authenticate. But first, I want to talk a little bit more about cryptography, because we talked about how we can use encryption to kind of, yeah?
Just I want to clear one thing. So encryption you want to use if you want to reuse the data. Hashing is when you don't need the data specifically. You just need to know that it's correct.
Exactly. So if you were logging in, you give me a password. I don't want to know what your password is. I just wanted to know if it matches my database. So I hash it. If you send me an important document, I want to know what that document is, so you are going to encrypt it. And we're going to talk about some of the ways to encrypt. Now, typically, yeah?
A quick question about encryption and hashing. Just given
Mhm.
For encryption and a hashing algorithm. If you put some string into an encryption algorithm, you can get a garbled string out, and then you can expect that you can always get the same string given your same input with the encryption algorithm.
As if the algorithm is the same,
Yes.
then with a given input, the output should be the same.
But with the hashing algorithm, then you would get the same input, unexpected results on the other side for output.
No, that should be the same as well. Because otherwise, how can you check the password? If your password is Apple, and then I hash it, and it becomes 94. Let's just say our algorithm gives us a number. If you log in, and you type in Apple, I have to be able to make sure I get the same output. Yeah. So both encryption and hashing will get you the same output with a given input. The difference is with encryption, you can go back. With hashing, you cannot. Now, let's talk about encryption for a bit, because that's what's used for transferring files from one person to another in a secure way. And now, the simplest way I could do it is kind of like, let's say something super simple. You write me a letter, and the encryption algorithm is shifting all the letters by 2. Now, when I receive that letter, I can use that decryption key, the same encryption key to decrypt it, and then read what the letter is. But someone who doesn't know it, like a person in the middle, even if they open that letter while it's going through FedEx, they have no idea what it says. That's the simplest way of doing it, but there's one thing that makes it imperfect. What might that be? Yeah.
Because it's two-way, unlike a hash, it's easier for someone to guess what the encryption method is.
It needs to be two-way though. That's the thing, because like I need to be able to read that file.
It does, but that is a downside.
That is a downside, yeah. And also, if I'm here, and this person's over here, in cryptography they often use the like placeholder names Alice and Bob. So Alice is here, Bob is here. Alice wants to send a letter that says hi. And then before she does so, she encrypts it, and it turns into, I don't know, 7.1. That's the encrypted file. Sends it over. So let's just say this is the like encryption algorithm, that little circle. So Bob also has this decryption key, the same encryption and decryption key. Well, it's the encryption key, but he just runs it backwards to take that 7.1 and then turn it into hi. This works, but the problem is, or the potential problem is that both of them have to agree on what that encryption key is. Which means at some point they would have to physically meet, or meet in a really secure way and say, okay, this is the key that we agree on. And that's really hard to do over the internet. In person, it's easy. You can just exchange a little card that says, hey, this means this, hey, this means that, and you're fine. But over the internet, how do you make that initial exchange? If I want to send a secure file to like a Nigerian prince or something like that, and I want to, exactly, he wants to make sure that it's secure. How do I make sure that we can agree on a key and this guy's not a hacker? Because I believe in him. I like to believe in people. Yeah?
You can communicate in an encrypted way using a Tor.
Yeah, that's one way. This guy knows the guy. Exactly. So that's like a potential thing that could happen. What sometimes could happen, what the server might do if you're communicating over a server, is that you could have a server here, and you negotiate a key with the server, and then this person negotiates a key, let's call it let's call it KB, and let's call it KA. So with the server that they're communicating, let's say it's like, I don't know, Google Cloud server or something like that, Gmail servers, then they don't ever have to talk to each other and agree on a key. Instead, Alice agrees on a key with the Google servers and says, hey, this is my key, use this to encrypt the thing that I send over. So now when Alice says hi, then that gets encrypted, and then it gets decrypted on Google's server, and then it gets encrypted again with Bob's key and sent over to Bob. So you have like this intermediary providing a little bit of security. Basically Google's saying, don't worry, I'll make sure. You guys don't have to talk to each other and agree on a key. Just agree with me, Google, and I will make sure that your files get across. But the problem with that is Google itself can be vulnerable. And you have what's called a man-in-the-middle attack, in which someone can access this server, and while it's in this vulnerable state, someone can access those files. Or worse, access those keys and then decrypt the files while they're on their way. So what you have nowadays is something called end-to-end encryption, in which you have the files being sent over without being decrypted on the way. But then this problem still remains. How do we make sure that Bob and Alice can agree on a key in a secure way? And this is where you get something called asymmetric cryptography. And I can't stand the way I draw, so I'm just going to pull up a picture that kind of depicts this a little bit more clearly. And then after this, we'll go on a break. Asymmetric cryptography, yeah. And it's something like this. Oh, wow, this picture. So you have something called a public key and a private key. And Alice and Bob both create a public key and a private key. And basically, actually this message doesn't describe it that well, but basically if, I have to start drawing again. Let's go back. Okay, Alice has a key public. Oh no, let's just say AK1 and AK2. These are two keys that Alice generates. There is no fundamental difference between either of them. One automatically just gets arbitrarily defined as a public key and a private key. But basically, any piece of data that is encrypted by one can only be decrypted by the other. So that means if hi is encrypted by this, it can only be decrypted by that. And if it's encrypted by this one, it can only be decrypted by that one. So what Alice is going to do is she's going to take one of those keys, make her private key, her public key. And that key is available to anyone as AK1. Bob is going to do the same. He's going to put B key 2 in the public. So if Alice wants to say hi to Bob now, all she has to do is take a message, hi, and then encrypt it with Bob's public key into something. And now anyone in the middle will get this message, but they will not know what to do with it because, why? Because any message encrypted by Bob's public key can only be decrypted by his private key, which only he has access to. And that's pretty much what happens. And then it goes the other way as well. And that can help you make sure that your message get across safely and that you can verify that it came from a particular person.
This is how you got
This is, yeah. No, I got my interview with the 2FA, which we'll talk about in a bit. But yeah, so that's AK1. That's asymmetric cryptography. It's very, very strong compared to what we've talked about so far, but it's still like imperfect. I mean, there is no foolproof security measure. I mean, potentially someone could like, I don't know, access one of these computers and get access to their keys, or send a message pretending to have someone's key, and then there's a lot of kind of like small holes that that can potentially be exploited. But in terms of like industry standards, asymmetric cryptography is a pretty reliable rule of thumb, and that's what's used when you see secure websites. If you ever go to a website and you see this little connection is secure, or HTTPS, then that means that the server is being, it's secure and it's verified, and it can be verified with this certificate that is validated with a certificate authority, and that's done with public and private key. So what the certificate authority does is it signs this certificate with a private key in order to kind of verify that this person or this website is who they say they are. So this, let's see, sh1grumweb.com is actually this website and not just some malicious website pretending to be. So to avoid phishing attacks, one thing to look for is these HTTPS connections that are verified with a certificate. I think we're going to go on a break now. So I think, how long is your break usually after your lecture? 10 minutes? OK, we'll give you guys 10 minutes, and then we'll come back and we'll talk about 2FA, and then we'll look at some code too.
I actually didn't understand what the difference between hash and encrypting was already. Like you meant hashing is one way and encrypting is two ways, right?
Yeah, exactly.
But, like, is there an analogy to that, or some example that you can explain?
Yeah, yeah.
Like, what he was confused about as well. Like, I thought hashing was every time it goes to the function, I would check that's why.
No. If you put two, if you use the same hashing algorithm on the same input, you should always get the same output.
So yeah, okay.
So if I take like a file full of a bunch of text, and I encrypt it, what I should get is a bunch of random text, but that has some kind of pattern. Like let's say all the zeros get turned to O's and whatever, all the letters get shifted. Like, if I know the algorithm, then I can go back. But with hashing, if I put it through a hashing function, then maybe the hashing function is going to turn all of that into a one-digit number, like 9 or 8 or something. There's no way for me, even if I know this, to figure out like how I got from that to the number 9.
But there has to be some sort of pattern still, right?
Okay, so I guess like
I mean, there could, yeah, if you know it, you can kind of guess.
Maps to the same value.
Yeah, because you're going to have stuff, exactly, you're going to have stuff that maps to the same value. You're going to have a whole lot of these that can turn out to be 9. So you don't really know how to go from 9 to that. 9, if you go backwards, it could be a whole bunch of different things.
so I guess like a way to think about this, encryption given a certain string, it's going to manipulate that string and do something on that string to give you a randomized output.
Yeah.
With hashing, given a specific any input, it's going to just generate you the same consistent randomized output with the given input.
Yeah, exactly.
Instead of manipulating the input to do something, it's going to just generate a new a thing.
Exactly.
That relates to this.
Exactly. You could print out a color or something like that.
Yeah.
And then you can only have like 3 potential outputs, like red, blue, and green.
Yeah.
And those 3 represent like the million potential inputs that come from it. So there's no way to map back to it because, like you said, like a bunch of inputs will map to the same output.
It makes sense, but then some way that this has to go through some sort of function with a certain pattern to get that color or whatever. Right?
Yeah. Let's think about it this way. Let's say our hashing algorithm, what it does is it takes all the numbers, all the letters in a string, gives their alphabetical values, so from 1 to 26, and then adds them up. So A, B will turn out to be 1, 2, which will give you 3. So that same algorithm, if you put in C, is also going to get you 3. So if you see 3, how can you figure out what came from it?
So is it right to say hashing is stronger than encrypting?
It depends what you're using it for. Hashing is much better idea if all you need to do is verify. like passwords. I want to make sure the password that you entered is the same as the one I have in the database. I don't need to know what they are. I just want to make sure that they're the same.
Okay.
So that's when I hash. If I want to, if I want to see what the input was, then I have to encrypt. Like a file going across, like a secure email from the government.
Because you would have to decrypt it.
You have to decrypt it.
So
Yeah.
in like all these websites that you log in, it's probably hashing.
It's probably hashing it. Yeah. Yeah.
I just looked at it. I looked at like the map between that pit, and I was like, no. I was just like, no. Where is the fucking?
Hey.
Sorry, I was a little late. I had an appointment.
Oh, no worries, no worries, no worries.
Yeah, I didn't. I'm loving the lecture so far.
Cool, I appreciate that.
I'm Aiden, by the way.
Nice to meet you, and Johnny.
Johnny, nice
Yeah.
to meet you, man. Yeah, I was just curious too, thinking. Maybe this is totally off topic, but how this relates to VPNs. Or sorry, not a VPN, but like a Tor encrypted browser.
Tor encrypted browser.
I guess again, I'm buffing the stuff out, but like when you're using that stuff, is it a form? It's some form of encryption.
Yeah, I don't know the answer. I can look into
Okay.
it for you, but yeah, that's not something I know too much about. I'll find out though. I'll let you know. I'll look into it. But I would imagine that it probably uses some kind of end-to-end encryption, whereas like some other kind of file sharing services like have the data stored within the server, like in a decrypted way. That's my guess, but I can't tell you for sure.
Okay, cool.
Yeah.
No, this is really interesting.
I find it super interesting too.
Yeah. Do you work in cryptography or what do you?
No, I mean it's funny because I'm at Axiom Zen and like they're most
Oh no way, dude! One of my really good buddies is there.
really what's the name?
Abhishek.
Oh,
we work
what?
together at Zynga. Yeah, dude.
That's awesome. Abby's the best.
Yeah, you know.
Yeah.
Small world.
Exactly.
Yeah,
So they're
yeah.
like their team, the CryptoKitties team, they're all about like cryptography and things like
Yeah,
that. The project that I work on is more front-end oriented, so I don't touch on a lot of that stuff too much. But
What are you working on?
it's called Zen Hub. It's a project management
Okay.
software. Yeah.
Oh, cool. Yeah, I heard about that. Yeah.
Yeah.
Nice, man.
Yeah. So is he the one who got you to join bootcamp, Abby?
Sort of. Yeah. I mean, I was working in product for a while.
Mhm.
And then I just kind of decided I wanted to like take a bit of a leap, do something more entrepreneurial. But it's been like I've done some coding in the past.
Okay.
But it's like was getting a little stale.
Yeah.
So that's why I decided, all right, like let me just take a boot camp to the point where I'm going to have like a higher level of knowledge, and I'll actually be able to whip together MVPs and stuff like that.
That's the thing. That's the reason why I started to do it. Because I'm like, I want to be entrepreneurial, but I want to be that guy who's like, hey, here's my idea on a napkin. Now build it for me.
That's
I want to be like, no, here's I can actually get started on my own,
Yeah.
and then get people to join in.
I wanted to get beyond prototyping on paper.
Yeah, exactly.
Yeah.
Oh, that's good, man.
So yeah, man. But actually, I did show him the curriculum here because I actually worked with one of the guys, Remy, who's the GM.
Yeah, okay.
But I checked out a bunch, and I actually showed him all. I've showed him a couple of people, but Avi's one of the guys, and he's like, "Yo, this is the best curriculum." So that's part of the.
That's
reason
good
I ended
news.
up here.
It's changed too. When I did it 2017, it was only 8 weeks.
Okay.
So you guys are getting spoiled. You're getting 12
so
weeks.
You did it here?
I did it. Well, it was at the old building, but like it was still in this
Okay,
neighborhood.
no way, man. Yeah.
Yeah,
I
2
remember
years
you guys were in that labs right by Victory Square.
Exactly.
Launch Academy with Launch Academy.
Exactly.
Yeah.
It was like it wasn't the nice as this, but it was still a good time. It was like probably the best decision I've made in my 20s for sure.
Oh, that's good to hear.
Yeah. And I've been a dev for like 2 years now, and I absolutely love
You're
it.
front end dev or?
I mean, mostly front end,
Okay, but
full
full
stack,
stack,
but
yeah,
like
yeah.
most of my work
Yeah.
is front end.
Cool, man.
Yeah,
Cool. Oh, it's
Yeah.
a small world.
it is
Yeah. I mean, that's Vancouver though.
pretty much.
Yeah. Nice.
Glad you're enjoying it.
You mentioned about hashing.
Yeah.
You could get, let's say, like 3. I know it's a small example, but you get 3. You said you can't go back because you don't know what it could be, right?
Yeah.
Does that mean, I know it's like impossible, but does that mean there could be more than one password from the client side to put in and get through the same?
Yeah. It's I mean a lot of hashing algorithms are going to be more complicated than that, so you'll get like a larger output. But potentially yes, there are different outputs that can get you the same input. But usually the good hashing algorithms are so complicated and the outputs are so long that like it'll be like almost mathematically impossible to get the same output. But it's not impossible. You're right. Someone could write if the hashing algorithm is bad enough, someone could put Apple, the other person could put like 72, and they can get the same hash. You never know. Yeah, there's no way to make it so that like there's absolutely no. The only way to do that would be to encrypt it, but then like you don't want to be doing that. You don't want to encrypt. Yeah.
Right, I'm not going through that whole package today.
Not you overkill.
I'm like, damn,
Or
okay.
overkill.
You're really going at it. It's only 11. 11 hours.
No, I forgot like
Okay, 1 hour. Okay, go for it. I just start seeing you typing your study really, really fast.
either that or read. Either read fast or
Oh, yeah. No, I'm hoping it's really fast so that you have like that thing on again. It's like 2,000 comma or something.
Okay, we're going to take a look at some code examples that go over some of what we've been. Oh yeah, of course. This will be very similar to what you all will be implementing in your Tiny app, I think. We all have an Express server running, hopefully, right? Okay, so we'll need to explain that. We have the body parser to interpret, to parse the body, as the name suggests. We're not going to use bcrypt for this one. We're going to use cookie parser. And then Morgan, which is a logging thing, but I don't know why it's there. I didn't really put it there. The important thing to pay attention to is the fact that we are using this. What does app.use do, actually? Anyone remember? Sorry? You don't know that. You don't know that. Brian, go ahead.
it allows the app to use some sort of middleware to do something.
Exactly, yeah. And in this case, we're using a cookie parser, and the argument that this cookie parser call takes in is the key that we use to sign cookies and make sure that they're ours. And this is going to be a very simple, it's a very contrived app. All you do is log in, and it takes you to a treasure chest. And one of the middlewares that's used is this check user middleware. So that's going to be run on every single app, on every single request. And if you make a request to the root endpoint, let's see if I can find it. It takes you to the treasure, but when it checks the user, it's going to look for the signed cookies for a value called current user. And if it's there, it's going to say you're logged in. If not, it's going to redirect you to the login page. So let's use it. I'm on localhost, and if I go to the root endpoint and I'm not logged in, it takes me to the login page. Now, I can take that as a given, or I can kind of dive deeper and see what's going on. What's one way? By the way, I don't know if someone showed you this already, but if sorry? There we go. Instead of running node server.js, I can run node -- inspect server.js, and that's going to attach a debugger to it. So now, if I have my app running, I should be able, unless I already have it open, but if I had it closed, I would see this little green node symbol popping up. I could click that, and it would open up, it would listen to a node server that's running, and if I click on sources, it would go to the files associated with that node server. So in this case, I can go to the server.js and attach a debugger to, or a breakpoint to this line over here. So now if I hit any endpoint really, then the debugger is going to stop. Let me see if I can put it on a different screen actually, so I can see more of the code. Can you see that okay? Yeah. So here in the request, I can see the signed cookies, and I see the current user is undefined. What does that tell us? What can I expect is going to happen based on what I see at this particular breakpoint? Yeah?
Basically that it's not like, it hasn't been set yet, so like no one has like logged in or anything.
Exactly. So the signed cookies right now, I can even go to the console and let's see. If I type in rec, I can see the request. If I type in rec.signed cookies, or no, is it signed cookies? Is it? Let's see. Readable state, readable. Yeah, it's signed cookies. So I'll just take that. And I'll do rec.signed cookies. And I see that it's undefined, which means there are no cookies. And based on the logic that we have in here, if there's no current user, then I just get redirected to login. So let's go and create an account. Well, first I'll let it play out. And I'll just make user, and I'll type in user, and I'll hit login. Oh, sorry, I was sign up. Yeah, user, create account, and now I can log in. I'm gonna deactivate this breakpoint for now. I'm inside, and what should I expect to see in the applications tab? I see the current user, and we can see that even though we don't have any encryption going on the server side, it seems like Chrome automatically kind of encrypts the cookies in a particular way. But when we actually make the request, we should see it in its original form. So I'm going to go back and reactivate my breakpoint here and just hit the root endpoint. When I do, I can see inside the cookies, I now have current user and user. So it's not encrypted at this point. Any questions about what's going on here so far? So all I'm doing is checking the cookie. And then, well, actually, before I even do that, when somebody signs up, where's post sign up? Or, sorry, when post login. Where's post login? Here we go. When someone logs in, I set the cookie with this line of code right here, line number 96. Say, response cookie, current user, and then username, and then sign true, which means I'm signing the cookie. So what that does is the response will, there will be a cookie attached to the response, and then that cookie will be set by the browser, and it will be saved in here. And let's see if I can find the network tab. And if you ever running code that has you going from page to page, but you want to see all the requests that happen along the way, what's one thing that you can do in the DevTools? Anyone know? No? OK, I'll show you. You can hit preserve log right here. And then now it's going to save all the requests. Oh, oh, it's still paused on a breakpoint. Let me deactivate it. OK, so I'm going to log in, user, and let me see if I can find the post request for the login. There we go. So here's a request that I made to my node.js. I made the request with the login, and I attached my information, and where are the cookies? What I requested was a current user cookie, and that's what I got. And that's what I ended up attaching into my browser. So now every subsequent request to the app that I built will have this cookie attached to it. So it gets attached as soon as you hit login, and the server responds with a successful login screen in that 200 response. So now we're going to take it one level farther and use encryption to actually store the cookie in a slightly more secure way. And we're going to use something called bcrypt. So let me see if I can find it in here. Bcrypt is a very common encryption package for Node.js. You can specify different ways that your data is encrypted. I can't remember off the top of my head what the default algorithm is. It might be SHA-2, but you usually can find it in the documentation. And what's going to happen this time around is when somebody logs in, we are going to take their password and compare it to the password in the user database. But that password itself is going to be encrypted. And that's going to happen with the bcrypt compare function. It's going to take the input password, it's going to hash it, and then compare that to the hashed version of the user password, and it's going to pass in, it's going to call this function. What's this function here called? What is it called when a function is called based on something else? Yeah, exactly. What was your name? Julia. Just like Julia said, this is going to be a callback function, and it's going to return an error if there's an error, and it's going to call a Boolean for whether or not it's matched. And if it's matched, then we can redirect them to the treasure. Otherwise, we just redirect them to the login page. So let me just put a breakpoint here as well. Oh, I actually have to start this. This is a different app altogether. There we go. It's using the same cookie, so I'll just clear it. And this time, let's put on the login screen, put a breakpoint right here, and user. No, did not get called. Host login. Let's see here. There we go. Okay, so I have an incoming request, and this request has a body, and it has a password and a username. So at this point, what I want to do is use that information to compare what I have stored inside my database, or in this case, just memory, to see if it matches. And let's take a look at what data looks like right now. So if I go to the console and I type in data, I have an array of no users, which makes sense because I actually haven't created any. But the logic is still going to run. And what's going to happen is it's going to say, find a user which has the username that's the same. Yeah. Can you see that better? Okay. Find a user that has the same username as the one that we're passing in. What do you think is going to be the return value of this? What do you think is going to be, if I put a breakpoint right here and I play it out, if I hover over user, what value do you think it's worth at this point? What do you think is its value? So I've made a request, and inside the request body, I have username as a user and user as a password. And then it tries to find a user inside the database, or the database, that matches the username. True? Keep in mind, I just typed in data in here, and I see users is an empty array because I don't have any users yet. So what is this going to be? Undefined. So find returns what it finds, and if it doesn't find anything, it returns undefined. And so now we're saying if there is no user, because I mean undefined is falsy, so if you put an exclamation mark in front of it, it gives you true. But if there's no user, redirect to login and then return. Otherwise, we're going to do a password check. So in this case, even if I have a breakpoint on 91, is it even going to get here? No, because of this return statement right here. So now we're going to run it again, but this time we need to actually make a user beforehand. Let me just turn these off for a second. I'm going to sign up and user 123, and I'm going to say password. Oh, sign up. Oh, I think I forgot to hit play after doing that. Okay, so we're going to do user 123. I'm going to say my password. Create an account. And this time we are going to log in. Let me turn these back on. User 123, and then my password. Log in. Okay, we hit the breakpoint. Now it's going to be a little bit more interesting. We have the input, user 123, and we have my password. Now we could go through the whole thing line by line to see what we get to, but I do like to go into the console and just play around with the variables that are in memory just to see what we got. So if I look at data right now, and data is defined in line, let me see if I can find it. Data is, oh, I just had it right here. It's just like our makeshift database, basically. Data is an object with one key users for which the value is the one that we just created. We have the username, and we have the hashed password. So we as a developer do not know what this person's actual password is. I mean, we can reverse engineer it if like the hashing algorithm is weak, or we do a brute force and all of that we talked about before. But like, basically speaking, we don't know what it is, and that's a good thing because we don't need to. All we need to do is compare the input's hash to the hash that the user that we have already in there. So that's what's going to happen over the next couple of lines. We're not going to hit this because now the user is truthy because it has a value. So this is going to turn out to be false, and we're going to hit breakpoint 91. And now we can compare. We're comparing the password that is put in with user password, which is hashed. So the .compare method takes two values. One is the plain value, that what the user is trying to log in with, and the second one is the hashed one that we're trying to compare it to. And it's going to take the first parameter, or the first argument, hash it, then compare it to the second. And if it's the same, it's going to pass in true into the callback, or false if it doesn't. And if there's something wrong in that hashing process, it's going to pass in an error. But I don't know what will cause that to happen. So in our case, what do you think we're going to get? We know that the password is my password, and we know that the hash is this. We have no idea, actually. There's no inherent way to know, so we're just going to let the hashing algorithm do its thing. And then we're going to put a breakpoint on 92, run it, and it looks like it's false, which means I messed up something. I think I might have typed in my password the wrong way. And we're going to get redirected to the login page. Oh, this page isn't working. Okay, I'm going to keep it simple, just put user. Oh, sign up, my bad. User, create accounts. Now, user. And so let's put a breakpoint here. Log in. Okay, match is true. And so now we're doing what we did before, which is setting the cookie to the username and then redirecting to treasure. So if I play it out now, we're going to get the treasure. Any questions about what's going on here? Yeah?
Where did we hash the password?
That happens on it happens on the post sign up.
Okay.
Where was it? Right here. Yeah. And the 10 has to do with like some way we configure the hashing algorithm. I'm not 100% sure how that works. I think so, yeah. KV knows a lot about that, so he'll probably be able to enlighten you on that. Yeah, he's really, really knowledgeable on security stuff. But yeah, it has something to do with the way you configure the hashing algorithm. I usually always use 10, because that's what I've been taught. Any other questions about that? Yeah, of course. Actually, let's find out. Honestly, you made me curious now. Let's look into bcrypt. Oh, wait, sorry, we skipped your, yeah, what was your question about it? My bad, because I was like, lingering in my head. Go ahead.
No, I was just looking at the dot find. I just thought that was
Oh, you haven't used find yet? Okay. Who has not used .find yet? Really? Okay. Oh, I love this one. Oh, you get, yeah. So let's say I have my array, or const my array equals 1, 2, 3, 10. So I could say, if I wanted to find which of these is the number 3, what would you do based on what you know right now? What would you type in? Iterate through for a loop, or what was it? Index of, yeah. So I'd say like my array index of 3, 2, or then if I pass a number that isn't there, it's going to give me -1. The problem with that is if you have things that are different. So let's say like I'll do my array push, and I add an object now. So name Johnny. And then I want to do this. Index of name Johnny, I get -1. Can anyone tell me why? Not necessarily. Let's do this instead. So I'm going to put this my array equals. I'm going to put it 1, and I'm going to put this, and I'm going to put 3.
Because it's not returning, right? Like, what is the index of it? Returns 0.
Oh, what did I do?
Returns -1 if it can't find it.
Oh, because it was const, of course. I'll just say my new array, or my R, there.
But it's looking for the name, which is why it's returning -1.
Is it?
It doesn't. It's not reading the Johnny. Like, if you just put in Johnny as a string, then you wouldn't get -1.
If I put in Johnny,
Well, if you pushed it in as a string.
yeah, if I pushed in Johnny as a string, it would work. Yeah.
Because it's an object, and we also didn't name the object. But like also just the fact that it doesn't check what's inside the object.
Yeah. So you're basically index of takes a value, and then it's going to look for that particular value. And so the value that you look for has to be pointing to the same object or the same piece of data in memory. So if I have 1, or if I have the string Johnny, these take up one place in memory in JavaScript. No matter how many times I reference Johnny, it's always going to be referencing the exact same piece of data. So if I say, I'm going to start using let's. Oh, where were we? Let's r equals Johnny 2, 3, and then r index of, and then Johnny, I get 0, which is perfect. This is what we're expecting. Because this Johnny right here and this one over there are pointing to the same place in memory. However, if I have an object that looks like name Johnny, and then I make another object with name Johnny, these look the same. That is, they have the same values, but they're two different pieces of data. I can manipulate one, and it's not going to manipulate the other. So that's why what I'm doing is I'm trying to find something completely different, which goes back, I think it was Brian that mentioned that, or was it Grayson? One of you mentioned that if I had to find something with a variable, then it would work. So let's just say user equals, yeah, then I'm pointing to the same thing. So name Johnny, and then r equals Johnny, or sorry, user 2, 3, and then now I do r index of user, then I get 0. So now it works because that pointer, that variable, is making sure that I'm not creating a new object when I call index of. I'm not creating a whole other object. I'm pointing to the original one that I defined before I put it into the array. So that's the difference. But that doesn't really answer why the idea of find is better. Because find, what it does is it allows us a way to kind of circumvent that. I don't have to make sure that I'm pointing to the exact same object in memory. Really, when someone's typing in their password, they're putting in something completely different that wasn't in memory before. So I want to make sure I compare that. So what I'm going to do now is use .find, and what find takes is a function. And that function is going to be run on every single item, and it's going to return the item as soon as that function has true. So let's say this. I'm going to say const. Have you used arrow functions before already? Yeah. Perfect. OK. So const is Johnny equals, takes a string, and then it returns name equals, or no, let's just say user object. And then it takes user, and it checks if the name equals. What is going to be the data type of the return value of this function? Oh, my bad. What is going to be the data type of the return value of this function? Boolean. So now if I have a bunch of users, so let's say const users equals Bob, and then name Alice. What I could do, is write a for loop to go through each one of these and then check. Or I could use .find and then pass in is Johnny. And it's going to run through each of these and return back the first one for which it returns true. In this case, there won't be any of them because none of them are named Johnny. Is Johnny. Return back user.name. Users dot. Oh, user object, of course. I need to redefine. Here, I'll just redo this. I'll say const check name equals, and then, yeah, this doesn't match that. It was pointing to the user that I defined before. My bad. So let's see. We'll take check name, and then we'll say user obj, and then user name equals Johnny. There we go. Exactly, yeah. It would not. For an object, you'd have to check. You'd have to run a for loop. Check name, undefined. Now, if in my users array, I add a new one with the name and I run this again, then I finally get it. Any questions about how find works? You can also run find index, and that's going to work the same as get index of, except instead of passing a value that you're checking for, you're running a function, you're passing in a function or a callback that's going to be called on every single one, and then it's going to return the one for which it matches true. Now, so some of you might be thinking, okay, well, what happens if you have more than one users with the name Johnny? Is find going to return all of them? And the answer is no. Find is going to return only the first one for which the callback returns true. What do you want to do if you want to return more than one? There's another array method that can give you more than one. Yeah? Yeah, or there's an even simpler one. Simpler. Filter. Filter. And filter, let's say users, filter, check name, gives you back an array of all the items for which that callback returned true, or a truthy value. In this case, there's only one, so it's an array with the length of 1. JavaScript tangent. Let's get back to security stuff. Yeah, okay. A couple things that I want to talk about before we kind of wrap things up is a really good way of storing or authenticating your users. And what might that be? I think some of you probably use it with some of the apps that you use, like Google and Facebook and things like that. Yeah. Two-factor authentication. What's that all about? Yeah, so you have your password and you have a one-time password. And that allows you to kind of have an extra layer of security so that even if someone somehow compromises the passwords in the database, they cannot log in unless they have one of your devices. And I think the idea, well, the kind of broader term is multi-factor authentication, MFA. And the ideal way, or the most secure way that people tend to use is with something you know, something you have, and something you are. So think about something you know would be your password. Something you have would be a particular device. So I can only sign in with this device, or a phone, or something that you have. Like Google will ask you to sign in with one of your Google devices, or iOS, one of your iOS devices. And then something you are is like, I a fingerprint scanner or a voice-activated scanner, something that is about you that cannot be changed no matter what device you have. Now, most MFA systems will not go that far. They'll just ask you for a password and a one-time login sent by your email or something like that. But it is the most secure way, well, one of the most secure ways for people to authenticate, and it's why it's used by a lot of big companies. Now, on that, I kind of want to tie it back to the story that I kind of brought in before, which is about Spotify login, the thing I got interviewed about. Now, the reason why it was relevant is because, in my opinion, the most secure way, except in some cases, I mean, nothing's ever perfectly secure, but if you're building an app, the most secure way to authenticate users is with a third party. That is a big trusted third party like Facebook or Google and something like that. And these services provide you with third-party login through a system called OAuth. Does anyone know how OAuth works? No? Okay. I have another diagram. This one I'm going to have to kind of walk through because there's a little bit to it. OAuth is all about you signing into Google and then using that Google login to sign in and do things with other places. And it has two benefits. One, it allows an app to have a login system that they don't have to manage. All you need to know is your user ID for Facebook or whatever. I never actually have to ask you to sign in to my app. I just get you to sign in with Facebook and then come back with a token that says, okay, I'm that person, and you're good to go. So it's very easy to manage, and it's very secure because Google, Facebook, these sites have security measures beyond what most of us are capable of. So it's easier to just kind of like manage it, let them manage it. But obviously, the risk is that if they ever get compromised, then you're pretty much screwed. OAuth works kind of like this. And to explain it, I'm going to go to one of the more involved examples. Is when you use Facebook or Twitter or Google login to make changes to those accounts through a third-party app. Can anyone give me an example of an app that might use a Twitter login to do things to your Twitter account? Or an app that might get you to log into Facebook and then do things to your Facebook or YouTube or something like that. Yeah, exactly. They might get you to, they might ask for your friends list, or they might ask for permission to post to your account, and if you grant it to them, then that's what they do. If you use TweetDeck or Hootsuite or things like that to manage your Twitter account, then that's going to use OAuth in order to do that. And the OAuth process kind of works like this. You have your registered app, so let's just use Hootsuite as an example, and that has is registered to Twitter, and then when you, as a user, go on Hootsuite, it's going to send you to Twitter and say, hold on, we can't make any, we can't access your Twitter feed or tweet for you or look at who you follow or whatever without first you granting us access to your Twitter account. So it's going to send them to Twitter for them to log in and authorize access. Once you've authorized access, then Twitter directs the user back to Hootsuite's server with a token. With a code. And then that code is then used by the server to request a token. And then that token is sent back to the server. And that token can now be used by the third-party app to make requests to Twitter's API on behalf of the user. If I tie back to the example to the app that me and my friends built, what we did was we had a registered app, and the registered app would have someone log in with their Spotify account. Then, after they log into Spotify and said, okay, Oxcord, which is the name of our app. Does anyone know why? Oxcord? Thank you. It was spelled Oxcord and no one got it, but so Oxcord would say, okay, the login form would say, log into Spotify. Do you want Oxcord to have access to your playlists, your playback controls, and things like that? And you would say, yes, I accept. It would send you back. Then Oxcord would say, hey, I want a token for this user named Parm. Parm was one of our teammates. He gave us the code, so he said it's okay. Can you let us do stuff to his account on behalf of him? And then Spotify will say, okay, well, you have the code, so that means he said sure. Now you can make requests. So now we can make requests to Spotify's API on behalf of Parm in order to add to his playlist, in order to play songs and pause songs and things like that. So that's kind of what happens here. You have first the login, which gets you a code. Then that code is used to request a token. And then that token is then used to modify the user's data or access the user's data. Yeah?
When you receive the code to get the code, why can't you just get
Get the token. The code itself, that actually, it seems like the code is used to make sure that the person is allowed to, well, the code itself is permanent, but the tokens are temporary. So the code, you get that once, and then that code is then used to make requests with certain kinds of scopes. So let me see if I can zoom in this too a little bit. There are different kinds of access tokens, and different access tokens allow different kinds of scope.
like if you have different websites, I don't know, you get the code, you know it's the user, and then depending on which website is using the API, you have different tokens, so you can use different.
No, you have one token. Yeah.
Would it be like as you access different parts of the app or the site, you have different tokens that, so like let's say you give a token for accessing this part of the site. Once you move to this part of the site or the app, you get passed back another token that gives you access to other things that are accessible from the scope that you're in within that site and app, or
Yeah.
you're constantly giving a token and then getting one back, right?
No. The token stays the same. Let me see if I can go to an app that uses. Oh, actually, ours does. I'm gonna go to. This is the app that This is literally my job. App.zenhub.com. Oh, app.zenhub. There we go. And we use authentication through GitHub. So let me see if I can. Yeah. Oh, this is work stuff. I shouldn't be showing it. Let me go to my personal. There we go. No issues, no nothing. No. That's our we don't say that word around here.
I'm sorry.
Yeah, it's basically, if you can imagine like Trello connecting to GitHub apps.
Oh, okay.
Yeah. GitHub issues is what I meant to say. Yeah. There you go. Let me see if I can find the GitHub token. I'm going to delete it after this so you guys can't access my stuff. But basically, in my local storage, I have, okay, you can't see all of it, this GitHub token. And when I first logged in, let me see if I can actually, I can't completely delete my user. When I first log in, it's not going to happen now because I've already granted it. I would have gotten a code, and then, well, you don't see the code. I would have been sent back with a code, and then I would have said, been prompted to log into GitHub, and GitHub would have said, do you want to allow ZenHub to make changes to your GitHub account and do this and do that? And I would say yes or no. And then I would receive a token, or ZenHub would receive a token, and it would store that in my local storage. Then with this token, ZenHub can make changes to GitHub. Yep.
So essentially, you get one token, but the token is basically defined under certain parameters.
Yeah, those parameters are called scope. Let me see if I can find the Spotify documentation. when you grant a token, you do so with any one of these scopes: follow, read, follow recently played, birth date, read, and then on the screen which you allow the user to access your Spotify information, based on what keys are within that request for the token, it'll say Oxcord would like access to this, or that, and if you agree to all of them, you say yeah, yep.
Oh, I get it.
Mm-hmm.
Given that you get the same token, right? And then couple months down the line, you want to update your functionality. Do you request a new token with extra parameters?
Typically, I mean, it's not the app itself. Okay, so I have an app running, and it can read users' playlists, but it can't play them. Then I build it out later to allow users to actually play them. Those old tokens that were requested and granted with the old scope no longer work. Because I can't say, well, they have a token, but they have a token that is allowed these scopes. And now you're asking to do all this? No, that's not going to work. Brand new token, and exactly. So you can revoke all the tokens when they're no longer applicable. What we can also do, and what typically happens is tokens expire after a certain amount of time. And that's usually about half an hour. And when that happens, you can request a refresh token with the old one. But usually, with most apps, the server takes care of that on its own, which means you don't have to go and you'll notice whenever you use a third-party app, it's not going to ask you to log in with Facebook every half hour. So the refresh token happens automatically by the server usually. But if you're coding an app, I mean, a lot of services like Passport's probably one of the most popular services for managing OAuth. They take care of a lot of that code for you. So let me go to Passport.js. If you ever want to have third-party login on your app for your final project, Passport.js is the best way to do it because it means that you don't have to write the code. I didn't know about this before, so my colleagues and I, we spent so much time turning that whole diagram, where is it? Turning this into code and figuring out how to manage that back and forth. It was the worst. That's why I wrote the tutorial so that no one else would have to struggle with that. That's the reason why I wrote the tutorial. I'm like, yeah. I don't want anyone suffering like that, so I'm just going to walk you through how to do it. But if I had only known that there's a service called Passport.js that just literally just does it for you, all you do is you pick a strategy and then put in the sample code that they want you to put in, and then it'll basically handle all of those logins for you. So you can have login with Twitter, GitHub, lots of different kinds of websites. Slack, Browser Shield, AWS for Reddit, Twitch TV. Yeah. So if you want to have, which I recommend, third-party login for your final project, Passport.js is probably the best way to do it. I mean, unless you're just doing a really simple login with if it's not going to be very involved, then you're probably okay with what you have. Okay, I think I'm going to wrap it up there. I'll be around for the next hour, but does anyone have any questions right now before we get into work session? Yeah? Yeah, of course. This one? Pardon me? Oh, this doesn't really have to do with a cookie. This is just about authentication. At that point, you building this app, choose how you want to store the cookie. So you, this is basically communication between the server and the third party, whether it's Google or Facebook, to make sure that someone says who they are. After that, once you've made sure who they are, then you take that information about them, whether it's a user ID or something, and store it in a cookie the same way we did before. This process doesn't involve any part of the cookie. What happens with the cookie is after all this is done. And then it's like a separate process, really. If you can imagine, let me see if I can draw it out really quickly. You have your client, and then you have your app, app.js, and then you have Facebook.
So client accesses your app. They sign in through Facebook, make sure they're okay. They authorize the app. And then now you know who they are. That's what this covers. What happens after that is really up to you. So you would use a similar code that what you had before, because now you know this person's user ID. You can go and like store a token in their browser. So it's kind of two separate things. They're both important, and you probably should do both if you're building a big app. But this doesn't really deal with cookies. Any other questions? Cool. I'll be here for the next hour. Yep.
Send us, will this be like part of the lecture? Or I guess just OAuth flow, but I was like, I couldn't see the full
Oh yeah, of course.
diagram back there, man.
I'll send this all to you guys.
Okay, cool. And then the coding as well?
Yes, yes, yeah. Hey.
I want to ask you about something on your on the Java on the Visual Code. Like,
Yep.
when you can you open it? Just
Yeah.
like when you highlighted something, I saw like something with orange background.
Orange
Probably
background.
some plugin or something that you have. I was wondering what that was.
Orange background. What do you mean?
So go to the login. I remember like no, go down actually to the. I don't know. You click somewhere and then the objects were showing orange.
Oh, was that when I was doing the debugging?
Yeah.
That wasn't with Visual Studio Code. That was with Chrome. I'll show you. So I think it's running right now. What I could do, like the debugger tool.
Yeah, I think it was something like in.
So it was like here, and then I went to. Oh. Let me see. Is it running right now? I think it is.
Server.
Yeah, let me go to localhost.
But you know what I'm talking about?
Yeah, let me show you. Let me show you. Localhost 8000. I think you're talking about. I don't know if you were talking about this. This, and there was stuff was showing in orange.
Yeah.
So it's just Chrome. So if I go to any page, and let me put this in a different window. And let me go to check user. Where's check user? There we go. Here, if I hit any endpoint, this.
Yeah.
Yeah, that's just Chrome. That's not Visual Studio Code.
Oh yeah,
So it's just when you go to the, if you run node inspect app.js, it's going to open up, you can have access to the debugger, and it's going to listen to whatever node server is running and see what files it's running from. Then you can go inside those files and put breakpoints, and those breakpoints are going to pause the code whenever it hits a particular place.
So in that it's just like whatever's in orange, it's just.
Oh, these are the variables,
the
yeah.
Variables and it gets all exposed.
Yeah, but if you want to explore them like in a more interactive way, you can just go into the console side and say like, okay, I want to know what the data variable is. Oh, I guess it's not defined. Let's see, I want to know what.
Is that something that you use a lot? Like when you're
I use this
running
so much at work, you have no idea.
pretty much all the time. Just
All the
always-
time, yeah. I can see what the request is. I can like start calling functions from in here just to see what things are like.
So you like just freeze the code and check the state of the application at
I-
that point.
Exactly, yeah.
So just run it like when you're gonna run the code, you just put inspect.
Before dash inspect, exactly. Node inspect server.js. And then when you do that, you're gonna see this thing turn green. I'll run it. Now if I hit this, oh, I gotta.
That's like a node thing. Like,
Yeah, exactly. Oh, lost it.
yeah, because
This turn green. You can click it, and you can see it.
I've seen that kind of stuff using Visual Studio. Like
You can do it with
C#
Visual
and stuff.
Studio, but I
Yeah.
haven't figured it out. It's a little bit tricky for me. But yeah, you can do it with Visual Studio Code as well.
Yeah, but yeah,
It's easier.
Yes.
Yeah. No worries.